Hello, Audrey, Sophia, and Michael. Thank you for sharing this lesson with me today. Today I wanted to talk about systems, what they are, and I wanted to use our solar system as an example. So a system is when you have any group of things that are acting on one another, influencing one another. So, like, you have your family, right? And you each have your emotions and your actions, and you're living together, and you're bouncing around, and you're playing off one another, and you have this influence over one another, and you react and you act. That is a kind of system. You've heard of, like, the water cycle, right? Rain comes down, soaks to the ground, it gets respirated by trees, it goes into bodies of water where it evaporates, and that cycle continues. That's also a system. Your body is a system. Your body is many, many systems working together. You have your lungs, which is part of your respiratory system. You have your heart and your veins. That's your cardiac system. You have your brain and all your nerves, and that's your nervous system. And we live in the solar system. The solar system primarily operates on the force of gravity. And that's the thing that keeps us stuck to the ground all the time. Without it, we'd all just float free. Now, the solar system is very large and very complicated. And there's something I like to say. All models are wrong, some models are useful. So I have drawn here, if you want to come closer, I have drawn here a model of the solar system, and I tried to be as to scale as possible. But it's so much more complicated than this. So this is just a very brief overview of the solar system. And it starts with the sun. The sun is massive. Stars are incomprehensibly large. You could fit thousands and thousands of Earths inside the sun, and you probably still wouldn't even have enough to fill up the space. That's how big the sun is. And because it's so big and has so much mass, it creates a lot of gravity. And that gravity is constantly pulling everything in the solar system close to the sun. It all wants to go crashing into it. But it doesn't. Instead, what happens is because you have that force pulling towards the sun, but you also have what's called angular momentum. This is that these planets have energy from before the solar system was made. It was all this big swirling cloud that was moving in every which way, and as things condensed into the sun and into the planets and into the asteroids, all that energy moving in different directions bumped into each other, and it got negated, right? It leveled out. And this is why, if we looked at the solar system from the side, so up here, this will be the sun, most of the planets are orbiting in a line. So that would be Earth right here. That's Mars, and then we got Jupiter, Saturn, Uranus, Neptune, and then Pluto's like way out there. I put Pluto up there in the corner because they wouldn't fit on my board. Right, and they all kind of circle flat around, right? Like a disc. It's like a disc. It looks like a frisbee. And that's because all of their energy going in the different directions got negated because stuff kept crashing into each other, and this was the average that was left, is this circular motion around the sun. So the planets want to be going this way, right? But the sun's pulling them this way, in towards it. And so that's what causes us to spin around the sun in a circle, or if you want to be more precise, an ellipse, because this isn't a perfect system. We don't go in a perfect circle around the sun. Sometimes we're closer to it, and sometimes we're farther away. And if we went in a perfect circle, we'd be the same distance from the sun at all times. So we actually go in an ellipse. And for some planets, it's more exaggerated. Like in the Earth's orbit, very close to a circle. Circle. But Pluto goes in this big ellipse. An ellipse is an oval. It's a stretched out circle. So if that's the sun is in the dot, the Pluto goes in this big ellipse around it. So sometimes it's pretty close, and sometimes it's very, very far away. So that's like the basics of orbital mechanics, and that's a big word. But an orbit just means to be going around something. You know, we go around the sun, we orbit the sun. You pull the drain out of your bathtub, you got a little rubber ducky, and it's going down the whirlpool, it's orbiting that whirlpool. Mechanics, mechanism, the action, the way something happens. So orbital mechanics is just saying the way we go around things. It's a very fancy way of saying that. Now, every planet in our solar system has moons. Earth has just one. We call her the moon. And I hope you know her. You see her up in the sky all the time. And she goes around us just in the same way the Earth goes around the sun. Some of these planets have a lot of moons. Like Saturn and Jupiter have dozens and dozens of moons. I don't remember the exact numbers, but I think Jupiter has like 47, 55, somewhere in there. Like, that's a lot of moons. And that's not counting their rings. Because all these planets out here, all of the big planets in the outer solar system, so we have the inner, outer solar systems. And this is divided by the asteroid belt, which is a bunch of little tiny rocks and ice chunks floating around in a belt. All of these planets have rings, but we know Saturn's the best because they're so big and they're so reflective. They're really easy to see. But all of these planets have rings. So each planet is into itself a system, an orbital system, just like the sun is to our solar system. So Earth, we have the moon, and we also have lots of satellites that we put up in space to take pictures. That's how Google Maps works. To make phones work, to make television, and even the internet work, and to collect weather data. We call them artificial satellites, because a satellite is another word for something that orbits. So you could call our moon a satellite. So we'll say that the ones we put up in space are artificial satellites because we built them and we put them there. They weren't there before us. And this principle of systems interacting on one another can go really, really big and really, really small, right? Like the solar system is huge. You can't picture how big it is in your head. Like the spaces I put in between the planets here does not do it justice for how big our solar system is. But our solar system is tiny when compared to a galaxy. And the galaxy is tiny, minuscule even when compared to the size of the universe, in which there are millions, billions of other galaxies, each with billions and billions of stars in them. And those stars all have systems, much like ours. And you get smaller, because we've talked about people, right? Your family system, the rain, the weather, that system, but also the molecules that make up our bodies, the atoms moving together and connecting to make those molecules act as systems. And while gravity doesn't play as big of a role at that scale, there are other forces that act in a similar manner to get things to stick to one another, to move around one another and interact. So, I have some follow-up work for you guys, and I think this will be fun. I want you to pick a cosmic system. So this is a system in space, right? because we've talked about the solar system in general, right? And I want you to pick a body in this solar system. So pick a planet, or the asteroid belt, or the Kuiper belt, or the Oort cloud. If you're really ambitious, you can look those up. Those are wonderful things to read about. And I want you to draw a simple chart, kind of like this one. You know, doesn't have to be perfect, doesn't have to have every detail in it, but to just demonstrate the dynamics of that orbital system. And share it with me. Share it, Miss Griffin, Janelle, and Mary. They can all get things to me. So if you share things with them, they'll get it to me. And really, I love thinking about all the different systems in the world, and I wanted to share that with you. And I think it'd be really cool to see just how complex our solar system is, because it's not just, right, what I've drawn here. Each of these things also has a big complicated system surrounding it. So go pick one of these planets, do some research, and draw me some of its system, right? Draw its moons, draw its rings, whatever else is going on with it. And share that with me. And if you guys are okay with it, I'd like you to share. I'll make like a little video sharing the work so you guys can see what each other have done. And I think that would be really cool. So thank you so much for hanging out with me for this lesson. I hope this all made sense. Please, 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 if you have questions, either ask the adults in your life or get them to ask me, or we really should figure out some system so we could communicate directly. But I'm working on that. So, wonderful. Love one another, love yourself. I hope you learned something. Have a nice day. I will see you guys later. Bye.